In this video, we'll be looking at, once again, polynomial inequalities. For this particular polynomial inequality, we're playing with a cubic. Again, in the last two examples, we looked at quadratics. The rules for dealing with these don't change. So we're still going to go ahead and look at this as though we're going to solve the cubic, and the only methods that we currently comfortably have to solve cubics is really by getting it equal to 0 and factoring it. There are other methods to use. Again, you can do the long and synthetic division. However, the long and synthetic division will cause a lot more problems with you in terms of the problem. So in most cases, your solving of these polynomial inequalities will result in factoring. So the first step I'm going to do is, again, I'm going to look for the largest power of x. I'm going to make sure that that term is positive. I'm going to move all the other terms with that term so that all that term remains positive. So in this case, I'll subtract the x and I'll subtract the 3 from both sides. In this case, providing me with x cubed plus 3x squared minus x minus 3 is less than or equal to 0. Now again, in most cases, I'm going to ignore the inequality symbol for just a moment while I go ahead and set this off to the side and solve it as though it's equal to 0. When I solve this, again, I'm going to use that grouping factoring method. Out of these two terms, I can factor out an x squared, giving me an x plus 3. Out of these two terms, I'm going to factor out a negative 1, giving me an x plus 3. This whole thing being equal to 0, it's going to factor into x squared minus 1 and x plus 3. Again, if you don't recall that, go ahead and watch previous videos in terms of these two terms having to be the same, giving me the first factor, and then x squared minus 1 giving me the second factor. Now with this done, it's still equal to 0. I could solve this, but I'm going to go ahead and factor this term even further, giving me x minus 1, x plus 1 as difference of squares. So now I have all the factored terms. Again, in the first quadratic example, what I did was I rewrote those factored terms over here, and that's actually what I'm going to do here to help me check the values later on, giving me this as the inequality when it's all said and done. But each of these are going to give me an x value, so x equals 1, x equals negative 1, and x equals negative 3. With those three values, I'm going to create my number line. My number line, I'm going to give myself some space here because I have 1, 2, and 3 values now to work with instead of just 2 like the quadratic. I've got a negative 3, I've got a negative 1, and I've got a 1. I'm going to go ahead and create my, again, table, drawing all those. I'm starting with my intervals, giving myself some space. Then going to have my test values. And then after my test values, everything down here is going to be my scrap work to make sure I verify my check. Don't forget for this one here, because the equal sign, and this is a polynomial, all of those values, anything that might be a solution, should have a bracket or a solid circle, and therefore in the intervals they should all have brackets on them. So in this case, I'm going to go from negative infinity to negative 3, bracket, from negative 3 to negative 1, bracket, from negative 1 to 1, bracket, and then from 1 to infinity. Now, because this is a number line test, you don't actually have to write all these values in. You could just fill in the values that you need for your final result if you feel comfortable with it. But for a lot of you, it might be helpful to actually write all these intervals down, get that skill and habit down on a regular basis. And then after writing each interval down, it might be easy to identify the values that you're looking for. So negative 4, say negative 2, in between negative 1 and 1 is 0, and then over here we'll go ahead and pick 2. And those are my test values that I'm going to end up plugging in and checking. So once I've plugged those values in, the next step again is to simply plug them up here, either again into the original equality. If you don't trust your math, you can plug them into this inequality here if you trust your math but don't trust your factoring. And then I'm going to go ahead and plug them here because, again, it's the most efficient way to do it. So when I plug them in, negative 4 being plugged into this is going to give me a negative factor. Negative 4 plugged into this one is going to give me a negative factor. And plugging negative 4 into this is also going to give me a negative factor. So again, it's not negative 1s across the board, but they're all negatives, and that's all that's really important in terms of identifying these. If they're not negative, then negative times positive and things will alternate, but in this case, negative times negative is going to be negative, is going to be less than or equal to 0. So that is going to check for me. When I plug in negative 2, this one's going to be negative, this one's going to be negative, but this one's going to be positive. So I have negative times a negative times a positive, and that's actually going to be greater than or equal to 0, so that section doesn't check. When I plug in 0, negative, positive, positive, and therefore negative does check. And you'll notice here as you get more adept with these things and the problems are not actually terribly difficult in terms of the check, then you can more or less skip steps. But if you skip these steps in here and you make a mistake arithmetically in your mind, I'm going to have to take more points off. Whereas if you showed the work here, I could give you more points. So if I plug in 2, positive, 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 everything is positive, and therefore that section doesn't check. Now, you'll notice something in this example as well as all the other examples that we've done is that it appears as though the solution sets tend to alternate. This is not actually uncommon. The only time that a value should actually not alternate is when the solution potentially can come up more than once. So again, if this factor and I got x equals 1 and x equals 1, then it is possible that at x equals 1, then you have a solution set here and a solution set here. Doesn't mean it's going to happen. It just means that it's possible for it to happen. In most cases, again, if you recall the rules based on your polynomial graphs, if we have multiple solutions of this, depending on how many solutions of this value we have, will determine whether or not the graph is going to cross there or bounce there. And in any case, it means that we don't necessarily know what's going to happen here, or we can at least attempt to assume what's going to happen there. With all that being said, you'll notice that I only have these two sections that are valid solutions, so those are the only two sections I'm going to actually graph in here. So there's my graph in terms of the solution set. And then my solution set in terms of my final answer is going to be the negative infinity to a negative 3 with a bracket, unioned with negative 1 to 1 with brackets. And that is how you would solve, again, a polynomial inequality. Again, most of the cases you'll have to end up factoring these things. Very few cases will you have to do anything else other than grouping factoring. Possibly at worst case, your second quadratic factor might not actually factor nicely, and if it doesn't factor nicely, you might have to do the quadratic formula. But again, those are really nasty problems, and working through them, it's just making sure that you remember all of the basic steps of everything that you've done up until that point. So that's how you do, again, a polynomial inequality.